Good morning, my dear students. Welcome you all to this session. Today's class, we are going to start with the new concept, solid shapes. Till last class, we have discussed about the two-dimensional figures. Two-dimensional figures is nothing but it has only x and y axis. Yes, it will be having only x and y axis, which means only two dimensions are involved to draw that figure. Okay, so that is the two-dimensional figures which we already know. Next comes our three-dimensional figures. Okay, so this topic was called as solid shapes. Okay, so we are going to deal with something solid. Solid is nothing but which is very fixed. Okay, so it will have three dimensions actually. X-axis will be there, Y-axis will be there, Z-axis will be there. Okay, so three dimensions. For example, using the length, breadth and height, we can draw one three-dimensional figure. Okay, so we need three dimensions to create a three-dimensional figure. Okay, so now I already given some examples of three-dimensional figures in previous classes like cube, cuboid, sphere. These are some of the basic examples, and those types of objects you will see in our day-to-day lives. Okay, cube, you can see it in like your Rubik's cube you will solve, right? That is one of the example of three-dimensional figure. It is a cube. Cuboid, brick which is used to construct a building. Brick, which is a simple example. Your geometry box, like many examples you can see. Sphere, it is a ball. Your cricket ball which you are using to play is your three-dimensional figure, right? So we are using three-dimensional figures in our day-to-day life. Okay, that this two-dimensional figures and all, you'll just draw it and you will just imagine something. You will draw in surface and you will see that this is two-dimension. But actually three-dimensional figures are used by us in our day-to-day life. Okay, so first I'll tell you there are some features in the three-dimensional figures. Okay, first I'm going to draw cuboid. This is your cuboid. Okay, cuboid is nothing but it is a three-dimensional shape of a rectangle. Yes, it will have rectangles. Okay, using a few rectangles we are going to frame a cuboid. So in the textbook in page number 179 you can see they have explained you what is meant by vertex, face and edge. Okay, you know vertex, usually what is vertex? When you study about vertex in angle and all, no, when you form a when two line segments or ray, okay, two ray touch each other at a point, that is called as vertex and they form one angle. Yes, two ray touch each other at a point is called as vertex. Same way here, two line segments or three line segments, any line segment touch each other at a point, it is called as vertex. Okay, how many line segments, that is not considered. Any vertex which touch each other, okay, that point is called as vertex. Okay, usually this region is called as surface, correct? Or plane, you will say it as plane. Okay, so in a box, if you take one geometry box or some box or brick, one side one surface will be there, up one surface will be there, that side, back, front, down, everything you will have some surfaces, correct? That surface is called as face. What it is called as face. So all the sides will have this side you will have, and opposite to that you have front, you will have back side, you will have down, you will have up, you will have all that region. That region is called as face. Next, this line segments you have, right? This line segment connecting this vertex is called as edge. The line segment which is connecting this vertex is called as what? Edge. So vertex you have, face you have, edge you have. So these are the basic things which you should know. Okay, so you can see in page number 179 many three-dimensional figures are given. Okay, some figures will have identical faces. Okay, some figures will have identical faces. Identical means what? They will be same, congruent. They will be same faces. It looks like same. Okay, that is the identical faces which is meaning. Okay, they have in the next page number 180, they have given you a clear explanation for this cuboidal box, cubical box, cylindrical box. That we'll see it. Okay, so when you see that, you will understand more clearly. See, this is one cuboidal box. This box, can you see this box? Center one box. In that you have face here, here, that side, this side. So 4 sides you will be having a faces. Okay, see, this face is in rectangle shape. This is also rectangle shape. So these two are identical, which means opposite faces. Okay, in cuboidal box, opposite faces will look same. Okay, this rectangular box and that opposite rectangular box, both are same. Likewise, this side you can see, this one and that one, both are same. Okay, so in cuboidal box, what is the property? All 6 faces are rectangle. So 1, 2, 3, 4, 5, 6. When you take a cover, okay, so if some parcel is coming in a rectangle shaped box, when you uncover that box, okay, when you uncover that box, all that side faces will be rectangle shape. Okay, when the box is in cuboidal shape, all the faces are rectangular. This can be asked in any type of questions. And opposite faces are identical. Identical means what? Same. They look same. Even this is a rectangle shape, we cannot say that this measurement and this measurement are same. Only the opposite faces, this one and this one are same. This small one and this small one are same. And this small one, this one and this one are same. So, even though they are rectangular, we cannot say that all are same faces. Opposite faces only identical. So, there are 3 pairs of identical faces. Yes, how many pairs are there? 3 pairs of identical faces. What are those 3 faces? First face, this one are same, 1. These 2 are same, 2. These 3 are same, 3. So, totally we have 3 pairs of identical faces. Next, did you understand now what are the relations we study based upon the faces in cuboidal box? Next comes our cubical box. Cubical box, it is very easy. All the sides will be square. Actually, why this all these rectangles are not same? Why it is not same? Because in rectangle itself, only opposite faces are same. Opposite sides are equal. That's why in cuboidal, opposite faces are identical. Not all the faces are identical. Did you understand? See, but in cube, all the faces consist of square. All 6 faces are square. Since square are all equal, we can say that all the 6 faces are identical. Did you understand? Here, in rectangle, opposite sides only equal. That's why when come to cuboid, opposite faces are equal. In cube, all the sides are square. In square, all the sides are equal. Appo, all the faces are identical. Next comes your cylindrical. Cylinder, you can see it is one solid shape where you have circle on the top and circle on the bottom, and side you have one curved surface. Yes, you can take any drum or any containers which is in cylinder shape. Okay, you take it in with you. Top, it is one circle. It is a lid which is closing a container. Down is the bottom of the container. Side one curved surface. They are saying that the circle on the top and bottom are identical. They are same. Both are same. Okay. So they have one curved surface and two curved faces which are identical. Curved surface is nothing but this one, the center part. Okay, two curved circular face na region, this one and this one are identical. So this is what the cylindrical box. Okay, so we have many types of box, which is nothing but cuboidal box, cubical box and cylindrical box. Okay, so many types of box are explained using the faces, how it is identical. Okay, for cuboidal box, how we are saying that it is identical, cubical box, how we are saying it as identical, and cylindrical box, how we are saying it as identical. That is very much important. Okay, and next I want to say you about right circular cylinders. You know what is meant by cylinders, because top and bottom will be circular faces and circular curved region will be there. Yes, that you know about the cylinder. Particularly, they are speaking about right circular cylinder. What is the difference between that? See, cylinder. Okay, this is what your cylinder, right? So, you in this you have circular face. Here also circular face. So, if it is a circular face, obviously it will have a center. Yes, the circular face will have a center, right? This also will have a center, this also will have a center. So the line segment, keep it in your mind, you have a center, automatically you will have one radius. Center means you have some particular radius. So now the line segment joining two centers of the circular line segment joining two centers of the circle will form perpendicular to the base, which means this is your base, down is your base. Perpendicular means what? It will form a 90 degree. Appo, if the line segment joining two centers forms 90 degree, that cylinder is called as right circular cylinder. Okay, right circular cylinder. Some cylinders will be there. We cannot accurately say sometimes like this. This is also one cylinder. Okay, but to the base it is not forming a 90 degree. Sometimes we cannot directly say that it is right circular cylinder. See, sometimes in the book itself they have given one example. Here, this is also one cylinder. Okay, but here it forms a point, center and a radius. But when I draw a line segment connecting two centers, it doesn't forms 90 degree. So this is not a right circular cylinder. So right circular cylinder means line segment joining two centers of the cylinder base, circular base, it should form a 90 degree. So it is called as right circular cylinder, which is very much important. Okay. Next I'll teach you about the cone. Okay, cone, you can see ice cream cone. In that it is like hollow cone. Cone is actually in the shape of hollow, because when you take one ice cream cone, you can fill something inside this cone, right? It will be like this. Your ice cream cone will be like this, where you can fill some stuffs inside it, which is the ice cream you can fill inside it. Okay, so we can put something inside this container. So this is a hollow. Okay, which means you can give some stuffs inside that object. Okay, so in this cone you have one circle. Okay, you have one circle and one curved region, which means this is not in a regular shape, but it is something like that. Okay. So obviously we form one circle here and one curve. One curve is there. Okay, so this is one of the three-dimensional shapes. So you can see a solid cone also. Okay, some objects will be in this shape itself. Solid now, everything will be covered. Okay, everything will be covered. It will be like some box and all. It is if it is cube, you take a cube, a Rubik's cube, it is a solid shape because nothing you can put inside it. It is fully completely contained of that cubes. Okay, so likewise you can form the cone also like that. You can see some objects like that. Okay, in that also we have a circle and one top region. Okay, next you have one pyramid. Okay, back side it will be like that, where you have all the sides triangle. Okay, it is triangle shape here, here also triangle shape, but sometimes the base means what? Down. The base of the pyramid will be, sometimes it will be square, which means it will look like this. All the four sides it will be what? Triangle, and base will be square. Sometimes base will be triangle and all the sides will be triangles. Like that also pyramids will be there. Okay, pyramid all you will see, you can see in that prism. When you learn about some prisms in physics, the prism will be in that pyramid shape only. Okay, the prism will be like with a square bottom. It will be like square will be the base, and top region fully, this top region fully, it will be a triangle shape. Okay, so those types of pyramids you can see there. Okay, so many types of three-dimensional shapes you can see it. Okay, children, in your day-to-day life. Okay, so I hope you all understood. So the main basics to learn this three-dimensional solid shapes is vertex, face, edges, and in certain objects you have certain properties that all the faces are equal, opposite faces are equal, that we will have. So those things you have to keep it in your mind. Okay, I hope you all understood, children. Thank you.